characteristics of matter. Okay, and if you see matter is something, all of us are made up of matter, whether it is me or a phone, everything is made up of matter. Okay, so with this very small introduction, so I will start sharing the screen, and I want you to read the sentence and tell me what you have understood from the first sentence. Okay, you start with chapter 1, Aishwarya.
Yes, ma'am. Chapter 1, Matter in our surroundings. As we look at our surroundings, we see a large variety of things with different shapes, size, and textures. Everything is everything in this universe.
Aishwarya, please stop. Aishwarya, what do you understand from the sentence? You just now read the sentence. No, what did you understand?
Yes, ma'am.
Again,
In our daily life, we see some materials which have different shape and size.
Okay. Can you name any one thing that you see? We see a large variety of things. We see many. Can you name one thing that you are seeing right now? Maybe
Table, ma'am.
Table. Okay. So we are seeing table. Then you are having the same. You are also having a pen, a book, whatever it is. So you are having a variety of things, and each of them are having a different shapes and sizes and texture. Right?
Yes, ma'am.
Yes. Yeah. So next student, then Akash. Read the next sentence.
Everything in this universe is made up of material, which scientists have named matter. The
Matter.
air we
Now you stop. Now you tell me this. What is the meaning of this? What is the meaning of the sentence that you read?
which is made up of material that is called as matter.
Matter. So now, no, just now Aishwarya told that she saw a table. So table is made up of say wood. So that is a matter. Then I told a book that is also made up of matter. So everything that we see is made up of matter. So you understood that?
Yes, ma'am.
Akash, you understood.
Yes, ma'am.
So again, okay. So what you do again, you read the sentence.
Everything in this universe is made up of material, which scientists have named the matter. The
Correct. Okay, continue. Okay, another sentence you read, right? Continue, please,
the,
Akash.
the air we breathe, the food we eat, stones, clouds,
Continue.
animals, even a small drop of water or of sand. Everything is matter.
Yeah. So everything that we
We can
see is no. Now you stop. So what does this particular sentence tell us? What
stones,
is the meaning?
clouds,
Cloud.
plants are
Hmm. Then what
particle of
else?
sand,
Uh, everything is matter.
small drop of water.
They're all matter. So see, there are two things here. See, plant, animals, and stones. All are matter. Now, can you tell me a difference between a stone and a plant? See, both are matter. A stone is a matter. Then the particles of sand is a matter. Plant is also is made up of matter. Animals are also made up of matter. Now, between these two, can you tell me a difference? Can you think of a difference?
Plant
Different shape.
Yeah, yeah. Differentiate between them. Any difference between the two?
planting.
Uh,
No, stone is a non-living.
Yes, very good. Excellent. So stone clouds, they are non-living, but plants, animals are living. So matter is present in both living and non-living substance. Like, both, whether it is living or non-living, all of everything is made up of matter. Very good. So next, I'll tell the student. Anjali,
Yes, ma'am.
next read the next sentence.
We can also see as we look around that all the things mentioned above occupy space and have a mass. In other words, they have both mass and volume.
Mass and volume. So we see that whether it is living, non-living, what is the important property that they have, or what is
Mass and
they have mass and volume. So mass means
weight.
mass is actually, yeah, it is, yeah, when you're multiple it, okay, we can consider it as in general terms weight. And volume is the space that they occupy. Okay, so that means what have we learned from so far, from all the three sentence, or I mean from the first paragraph, what have you understood, Anjali?
Yes, ma'am.
What have you
When we say one thing is one object is matter, it almost it have a it occupy the space and it have a mass where then
very
we
good.
say that object is a matter.
Yeah, actually, everything around us is matter, and this matter will occupy space, and it will have a particular weight. Okay, we can call it as mass. So we just use, okay, for time being, we'll use the word mass. So this is the what we understand. So everything, see, maybe a curtain here. So this curtain is made. See, this curtain is made up of a particular material. So this is matter. So we, all of us, are matter. And this matter can be living, non-living, it will occupy space, and it will have particular amount of weight. Okay, so all of you understood this point?
Yes, ma'am.
Okay, next, Bhumika.
Yes, ma'am.
So go to the next paragraph.
Since early times, human beings have been trying to understand their surroundings. Early Indian philosophers classified matter in the form of 5 basic elements: the Panchatattva, air, earth, fire, sky, and water.
Okay, now
According to
we'll stop here. Okay, so what is the meaning of the two sentences that you read?
early times, human beings are not understand their surroundings like trees, and early Indian philosophers classified in 5 elements. There are earth, air, water, fire, and sky.
Okay, so the first sentence is since early times, human beings have been trying to understand their surroundings. Okay, and what did the Indian philosophers say? Matter is classified into?
5 elements.
Very good. What are the 5 basic elements?
Earth, air, water, fire, and sky.
Very good. And this is called as Pancha Tattva. They called it
Yes.
as Pancha Tattva. So from ancient time, sorry? Yes, you wanted to tell something?
No, ma'am.
Okay. So that means that means this that is, people have been always trying to understand these surroundings from long time. Okay, very good. So next student, Danya.
Yes, miss.
Now you read the next sentence. Okay. So after read the next sentence.
According to them, everything living or non-living was made up of these 5 base elements. Ancient Greek philosophers had arrived at a similar classification of matter.
Okay. So what do you understand now from these two sentences?
Matter is made up of air, earth, fire, sky, water.
Very good. So Indian philosophers, they believe that all matter, whether it is living or non-living, is made up of these 5 basic elements: air, earth, fire, sky, and water. Then what is the meaning of the next sentence?
Ancient Greek philosophers had arrived at a similar classification of matter.
Okay, what does that mean? What does it mean? It means that even Greek philosophers, not only Indian philosophers, even ancient Greek philosophers also, they also arrived at similar classification of matter. They said that there are these 5 basic elements present, isn't it?
Okay. Okay, miss.
So what is the meaning of the second sentence?
Greek philosophers also arrived that matter is made up of these similar classification.
Yeah, these five. That is, you have what you call Panchatattva, 5 elements present in the matter. So they also arrived at the similar classification of matter. Very good. Okay. So next, Madhumati.
Yes, ma'am.
Yeah. So read the next
Modern
sentence.
day scientists have evolved 2 types of classification of matter based on their physical properties and chemical nature.
Okay. Next sentence.
In this chapter, we shall learn about matter based on its physical properties. Chemical aspects of matter will be taken up in a subsequent chapters.
Chapters. Okay. Now, what did we understand from the earlier sentence that you read?
In modern day, scientists classified the matter into based on their physical properties and chemical nature.
Very good. So, what do you mean by physical properties? Any idea?
The
See, yeah, very good. Tell. You're attempting, that is good. What is the meaning of physical properties?
they are not changed, ma'am.
Not change meaning. So, for example, I have here, I don't know, can you see me? If you can see me, I have water. Okay, so you say water is a liquid. Okay, so that is what we see outside. It means the physical properties is what we see. For example, we see a mobile, we see that it is made brown in color or it is made of glass. This is what we see. Chemical nature is what is it actually made up of. Suppose a mobile, you have the glass part. What is glass actually chemically made up of? What are the small component present? What is the actual inner nature of glass is the chemical nature. Okay, so we had the matter. We can have 2 types of classification of matter based on its physical properties and the chemical nature. So in this chapter, what are we going to study? In this chapter, the second sentence meaning?
We are going to study that matter is based on its physical properties and chemical properties.
So we are going to learn about matter based. That means we are going to learn about the physical properties of the matter. And in the next chapter, the subsequent chapters, we'll learn about the chemical aspects of matter. Right? So what are we going to learn? We are going to learn about the physical properties of matter. Yeah. So you understood, all of you? Any doubts so far, students?
No, ma'am. No, ma'am.
Okay. Very good.
Ma'am.
Okay. Next is Mahalakshmi. So Mahalakshmi, look, okay, 1.1, you please read from there. Read the heading.
Physical nature of matter. Matter is made up of particles. For a long time, 2 schools of thought that prevailed regarding the nature of matter. One school believed matter to be continuous like a block of wood, whereas the other thought that matter was made up of particles like sand. Let us perform an activity to decide about the nature of matter. Is it continuous or particulate?
Very good. Now tell me, what have you understood from this particular paragraph? So we are taking.
Ma'am, here there are.
Please continue.
Ma'am, here there are 2 schools, ma'am. They thought they are studying about nature, ma'am. They start fighting, ma'am. I am correct about nature. One school thought that, ma'am, like wood is a rigid, no, ma'am. one school thought that the matter is rigid like the wood, and one school thought that uh, the matter is made up of the particles like sand, ma'am.
Very good. So actually, one school thought that it is like, it is made up of big blocks, and another school thought that no, it is not made up of big blocks. It is made up of small particles. So small particles together, they join together to form the matter. Okay, so these were the two schools of thought. So now let us see how. I mean, we'll do a simple experiment to see whether the matter is made up of continuous particles, or it is continuous material like blocks of blocks of wood, or it is made up of small tiny particles like sand. Okay, very good. So next person, Mantesh.
Yes, ma'am.
So now, yeah, now you read this. So there is an activity. Now read this activity.
Take one beaker,
Hmm.
fill half the beaker with water and mark the level of water. Dissolve the some of salt or sugar. Help of half a glass. Observe any change in water level. What do you think has opened the salt? Where does it dissolve? Where does the level of water change?
Does the level of water change? So what is this activity? What should we do? What have you understood?
Ma'am, one big is
Yeah, take a beaker.
the half of beaker water
Correct. Yeah. Then what do we do?
and observe the change.
Right. What do you think will happen? Any idea, Mantesh? When you add the sugar or salt to water, what do you think will happen?
Water level same, ma'am.
Very good. Water level will be same. Now, why will water level be same? Why do you think water level will be same? No, you're right. Very good. Water level will be the same. Now, any idea why water level will be the same? Anyone else can tell why water level is the same?
Ma'am, because it gets mixed with the space
Aishwarya.
between the.
Yeah, okay.
Yes, ma'am.
Aishwarya, tell me why the water level will be the same?
In water, there are particles of particles of matter have spaces between them, ma'am. So salt or sugar particles are very small. When we dissolve it, it goes in the space which is in the water, ma'am.
Very good. So we'll do this excellent. So what I'm doing is I'm adding water here. Can you see?
Yes, ma'am.
Yeah, I've marked it also up to a particular mark. I have marked. Okay. So I will take first little amount of sugar. A very little amount of sugar. Now I have added sugar here, and I'll just go on stirring. Then it will go into solution. See, in Bangalore, it is cold now. So since it is cold, what is happening is it is taking more time. Now, suppose I heat, what will happen? Suppose I heat, what will happen, Anjali? Suppose this water is warm and I add a small amount of sugar. What will happen? See, if I am stirring now, it will dissolve faster.
It dissolves very quickly.
Faster. It will dissolve very quickly. It will dissolve faster. Why is it? Why does it dissolve faster? Because of the increase in temperature. When the temperature increases, it is dissolving faster. Okay. Now the activity that we saw is the mark. Because I've added sugar, still the mark. The mark. There's no change in the level of water. So this, as you rightly said, because there is space within the water and the sugar particles have gone into the space between the water particles. This is the first point. Second point, as I told you, like when you increase the temperature, it will go into solution faster. The particles of sugar will, what you call it as, it will dissolve. We say it will dissolve faster. Okay, so this is the first activity. So all of you have understood. Any doubts?
No, ma'am.
No, ma'am.
No,
You
ma'am.
all understood. Very good. Okay, now, okay, who was the last person? I think Mantesh, no? Mantesh read?
Yes, ma'am.
Mantesh, you continue reading. That there is a small paragraph left and the figure left. So please read that.
In order to answer this question, we
Now continue. In order to answer these questions, we... Sorry, I can't hear you. In order to answer these questions, we need to use the idea that matter is made up of particles. What are there in the spoon? Spoon is a matter. Spoon is made up of matter, salt, sugar. What was there in the spoon, salt or sugar, has now spread through water. So we have a diagram. So what is the title of that this one figure? Mantesh, can you read that?
When we dissolve the salt in water,
Hmm.
the particles of salt get into the space between particles of water.
Between particles of water. Excellent. So this, all of you can see this figure. So particles of water magnified. This has been magnified. It is made very big, and we can see that when we add salt or sugar and when we stir, it will dissolve. And we cannot make out. See now, if you see now, if you now we'll just see this. Now, can you make out that this sugar has dissolved? Can anyone say that this sugar being dissolved here? Bhumika, can you see?
Yes, ma'am.
Can you see sugar in this? Can you see that how? Could you see how sugar went into water? Could you see?
No, ma'am.
You couldn't see, right? Okay. So now, how do we see? How can we see sugar going into water? So we will. The next activity will tell us where. Next activity will help us to see how these particles go into water. So we will look into that. The next experiment. So who is the next person? Mantesh is there next. After Mantesh, it is, I think, Naveen. Is it? Okay, Naveen.
yes, ma'am.
Now you read the next 1.2. What is it? This one heading.
How small are these particles of matter?
Very good.
Take a
Read that.
2 to 3 crystals of potassium permanganate and dissolve them in 100 ml of water.
Water. Okay. Then
Take out approximately 100 ml of this solution and put it into 90 ml of clear water.
yeah. So take
Take out
about
10 ml
10
of
ml. Yeah. Right. Continue.
Take out 10 ml of this solution and put into another 90 ml of clear water. Keep diluting the solution like this 5 to 8 times. Is the water still colored?
Okay. Oh, let us see this. So yeah. Before I show that experiment, just read out the heading of this figure. Naveen.
Estimating how small are the particles of matter with every dilution, though the color becomes light, it is still visible.
Though the color, though it is becoming lighter and lighter, still we can see. Okay. Now read the next paragraph.
This experiment shows that just a few crystals of potassium permanganate can color a large volume of water, about 1,000 liter. So we conclude that there must be millions of tiny particles in just one crystals of potassium permanganate, which keep on dividing themselves into small and smaller particles.
Very good. So what does this experiment tell us? Okay, Naveen, what is this experiment? How do we do this particular experiment or activity? How do we do this? What have you understood?
First, we take a 2-3 crystal of potassium
Permanganate, very good. Yeah. And then?
and dissolve them in 100 ml water
Very good.
and take out 10 ml of that solution and put into 90 ml of clear water
Hmm. Very good.
and again take out 10 ml of solution and again put into 90 ml of clear water.
Very
This
good.
this type
Ah.
of process
Hmm.
5 to 8 times we do and
Hmm.
it is smaller.
We see that the color will go on reducing, but still we can make out the color of potassium permanganate, which is sort of pink color, isn't it?
Yes, miss.
Yeah. So what does this experiment tell us? So this paragraph is there, no? This experiment shows that just a few crystals of potassium permanganate can color a large volume of water. So we conclude, we understand that there must be millions of tiny particles in
Million
this.
of tiny particles
Uh, uh,
are in just one of crystal potassium permanganate,
very good. And this keeps on dividing into smaller and
dividing
smaller.
themselves into smaller and smaller particles.
Excellent. Very good. So, okay, next paragraph, you please read. What is it saying?
The same activity can be done using 2 ml of Dettol instead of potassium permanganate. The smell can be detect, detected even on repeated dilution.
So, what has happened is we can use potassium permanganate, we can use copper sulfate, so we can use colored material. Now, suppose we don't have that, we can even use Dettol. So, I am going to
Dettol.
use Dettol. I'll use Dettol here. So, what I will do is I will take about, say, 100 ml of water. Anyone has used Dettol, added Dettol to water? Anyone has done?
Yes, ma'am.
Okay. What happens when you add Dettol to water? What happens when you add what change? So let us say. So when I'm adding Dettol, Dettol is this color. See here, this is Dettol is which color is it? Pooja, Pooja Ashok. What is the color of
Yes, ma'am.
Dettol? What is the color of Dettol now? Can you see?
Maroon,
What is the
ma'am.
color?
Brown red color में.
Brown color. Okay. So I took 2 ml. I took 2 ml from a teaspoon and I'm adding. So what is the color now? See, can you see?
White.
White. It
White, ma'am.
becomes milky. It
White,
becomes
ma'am.
white. White
White
color. White. So why does it become white? Any idea? So the brown liquid, no, which I added to water, the particles are moving and getting in between water. So when they're getting in between water, what is happening is what we see is this white color. See now sugar solution, you can see it is clear, no?
Yes, ma'am.
Sugar solution is clear. It is transparent. Whereas this is not transparent. This is turbid. Okay. Now I can smell Dettol. Right? Now I will go on diluting. Suppose I will dilute this. I will add it to another. Say I'm taking another beaker. In this beaker, I'm adding a small quantity. So if I add a small quantity, see the difference. So this is very turbid. This is it is lighter. No, can you see the difference? Sachin, can you see the difference? Sachin, can you see the difference?
Yes, miss.
Yeah, you can see it is lighter, and still I can smell Dettol. Okay, so in the other experiment with the sugar, we could not see how sugar or salt dissolved, or how it and how the particles got into the space between water. Whereas in this case, in case of Dettol, we can see, and what we see is it is becoming uniformly turbid. Uniformly, it is becoming cloudy. And that when you go on diluting, it becomes lighter and lighter, but still it is visible. The experiment says it is still visible. So all of you understood this point? Yes or no?
Yes, ma'am.
Okay.
Yes, ma'am.
So now very good. So now the Pawan will tell me he will give me the conclusion. So what is that? What is written in the blue color, Pawan?
The particles of matter are very small. They are small beyond our imagination.
Yeah, they're very small, beyond imagination. We cannot see them with our naked eye. But if you use a microscope, a very advanced microscope, we can see the particles. I mean, but some particles still we cannot see. So, but the point is, the particles of matter are very small. Okay. So now, Pawan, you continue. 1.2. We are now going to look at the characteristics of particles of matter. That is, what is the properties of particles of matter? So please read that.
Particles of matter have space between them. In activity 1.1 and 1.2, we saw the particles of sugar, salt, Dettol, or potassium permanganate got evenly distributed in water. Similarly, when we make a tea, coffee, or lemon-do, limbufani, particles of one type of matter get into the spaces between particles of other. This shows that there is enough space between particles of matter.
Very good. So what does this tell us?
The particles of matter have space between them.
Yeah. So what we discussed, this is the first characteristic or first property of particles of matter, that they have space between them. The space can be more, the space can be less, but it is there. Okay. So we saw that in sugar or salt at all, they get distributed, evenly distributed. Evenly means, what is the meaning of evenly distributed? Any idea?
Uniformly, ma'am.
Very good. Uniformly distributed. They get uniformly distributed in whatever matter. In this case, it is water. So similarly, when we make tea, coffee, lemonade, see, when we make nimbu pani, lemonade, when we add sugar or salt and then stir, it will be uniformly distributed. And the particles of one type of matter will get into the particles of the that is the other matter. And so we can conclude that there is space between the particles. So first we saw that matter is made up of particles. They are very small. And now we are seeing that. What is the point we are seeing now? Okay, what does this paragraph tell? We just now we've just now discussed now. Pawan.
Yes, ma'am.
What do we say now? What can we tell after? I mean, what can we summarize from this discussion? I just want you to repeat. We have already summarized. I want you to repeat.
Particles of matter have space between them.
Very good. Very good. Okay. So next, please continue. Now, please see the activity. Read the activity. First activity.
Put an incense stick in a corner of.
No, first read the heading, because this is
particles of matter. Particles of matter are continuously moving.
Okay. So what is the
Put an inlet incense stick in a corner of your glass. How close do you have to go near it so as to get its smell? No, light the incense stick. What happens? Do you get the smell sitting at a distance? Record your observations.
So what is the activity about? What have you understood? What have you understood from this activity? What should we do? What is an incense stick? It is that udbati,
Agarbatti.
udin kadi, agarbati. Very good. So what we should do, it seems, in this activity?
We put agarbatti in a corner of our class.
So how
We
close do you
go
think
to
we should?
How close do we have to go near it so as to get its smell?
Yeah. So how close do you think we have to go to get the smell of agarbati?
The particles of matter are continuously moving, ma'am, because
Yeah. See, if you take agarbati just like that, you take agarbati, we'll have to keep it near our nose. Only then we can get the smell, isn't it?
yes, ma'am.
But suppose I light that agarbati and keep it, we can see the whole room, maybe the next room also, you can get the smell, isn't it? Yes or no?
Yes, ma'am.
Yes. So
Yes,
what
ma'am.
all of you can do, you can just go, take an agarbati, smell it, and then keep it, light it, and then see till where the smell, we can get the smell of the agarbati. So you can do a simple experiment at home, and you can, you can record how far you can smell the agarbati, all of you. So this is, see, actually chemistry, all around us we have chemistry. So whatever, for example, cooking also, there is a chemical reaction taking place. So what we can do is we start observing, and then we can start enjoying chemistry. So this, all of you please do this experiment. Is it clear? Is it all of you have understood what I said? Sachin,
Yes,
have you
ma'am.
understood? Okay. So you should do this and tell me next class. I'll ask one of you, what did you do? What did you see? Okay. So next we'll go to the next activity. This is another activity which we can always do. So puja.
Yes, ma'am. Activity 1.4. Take 2 glasses or beakers filled with water. Put a drop of blue or red ink slowly and carefully along the sides of the first beaker and honey in the same way in the second beaker. Leave them undisturbed in your house or in a corner of the glass. Record your observations. What do you observe immediately after adding the ink drop? What do you observe immediately after adding a drop of honey? How many hours or days does it take for the color of ink to spread evenly throughout the water?
Okay. So what have you understood, Pooja, from this activity? What we should do? How we
Ma'am,
should do?
after this activity, the ink drops moves downwards and it particles spread in the water. The mixing of ink in water takes about 2 to 3 minutes. But the honey drops stick to the bottom of the beaker and moves very slowly.
Hmm.
The mixing of honey in the water takes an about hour.
Okay, very good. I see. If you don't mix, how long do you think that ink will take to spread? You mix the ink or you just left it, Pooja?
Yes, ma'am.
You did this experiment in your school. Did you do this experiment in your school?
No, ma'am.
No. All of you can do this experiment also. Just take a small glass and add carefully from the sides. You add ink, either red ink or blue ink, and then see what happens. Then you see how long it takes for it to completely dissolve, spread uniformly, spread. Right? Then similarly, take another glass, add either honey or you can even add jaggery, a piece of jaggery. And then jaggery color, you can see how long it takes for this jaggery to dissolve and and form a uniform solution. Uniformly to dissolve, how long it takes. And you can just record your observation. So if it is ink means how long it takes, for honey to uniformly, for the particles of honey to uniformly distribute within the water particles. Okay, so this experiment also you must try. So when you try, you will understand it. You will be, we all know, actually we know this, isn't it? All of us know this or not? Prerana? Prerana?
Yes, ma'am.
Yeah, this activity, when we read, we can understand, isn't it? We know what we will see, isn't it?
Yes, ma'am.
Yes. But here, what you do is you record the time. So you know, get an idea of how fast ink, what you call it, dissolves, and how long it takes for honey or jaggery to dissolve. Right? So all of you understood? Any doubts?
No, ma'am.
No, ma'am.
Okay.
No, ma'am.
Okay. Okay.
No,
Very
ma'am.
good. Now we will take Pratiksha. I will read the next part, Pratiksha.
Yes, ma'am. Drop a crystal of copper sulfate or potassium permanganate into a glass of hot water and another containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom. What do you observe just above the solid crystal in the glass? What happens as time passes? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? Why and how?
Very good. So what is this activity about, Pratiksha?
Ma'am, we should
What
take a crystal of copper sulfate or potassium permanganate into a glass. We should put it in hot water and another container of cold water. We should not stir the solution. Allow the crystals to settle at bottom. Then we should observe what happens.
we should observe what happens. So when you're heating, what is the effect of temperature? We have to,
Ma'am,
hmm,
in the
yeah,
hot water, the it dissolves quick faster than the cold water because of the kinetic energy. As the temperature rises, particles move faster. So if the temperature increases, the kinetic energy increases, so particles also move faster and then dissolve.
very good, excellent. So that means the particles are having kinetic energy, they're moving. So with the help of kinetic energy, they're moving. Particles are moving, and this process, what is it called as, the process of the solid particles entering into liquid? What is it called as? Any idea? Prerana, anyone?
Diffusion.
Very good, excellent. It is called as diffusion. Excellent. So, Pratiksha, read the next part.
From the above three activities, we conclude the following. Particles of matter are continuously moving, that is, they possess what we call the kinetic energy. As the temperature rises, particles move faster. So we can say that with increase in temperature, the kinetic energy of the particles also increase.
Very good. So, with increasing temperature, the kinetic energy of the particles also will increase. Okay, very good. So, next, continue.
In the above three activities, we observe that particles of matter intermix on their own with each other. They do so by getting into the spaces between the particles. This intermixing of particles of two different types of matter on their own is called diffusion. We also observe that on heating, diffusion becomes faster. Why does this happen?
Okay. So, what have you understood from this particular paragraph?
Ma'am, in the above three activities, we saw that particles of matter are intermixing on their own. We are not stirring them; they are intermixing on own. This is because of the intermixing of particles of two different types on their own is called diffusion. This is because of diffusion, and also on heating, diffusion becomes faster. So, this.
Yeah, diffusion. So, the question is why it becomes faster. Okay, now please read the next paragraph, Pratiksha. What
Yes,
is
ma'am.
it given? Hmm.
Ma'am, activity is there.
What is it?
Ma'am, it is about the second It is just like one group of chain people they are telling. Just I'll
Yeah.
read it, ma'am.
I think what now that I wanted the point is it is regarding a number of girls dancing, isn't it? As a chain, they're dancing.
Yes, ma'am.
Okay.
Yes, ma'am.
Now, yeah. So I think we have 1 minute we can spend on it. Yeah, please read that. Chain. Yeah, read that.
Particles of matter attract each other. Play this game in the field. Make 4 groups and 4 human chains as suggested. The first group should hold each other from the back and lock arms like Idu Mishimi dancers. The second group should hold hands to form a human chain. The third group should form a chain by touching each other with only their fingertips. Now the fourth group of students should run around and try to break the 3 human chains one by one into as many small groups as possible. Which groups was the easiest to break? Why? If we consider each student has a particle of matter, then in which group the particles held each other with the maximum force?
Yeah. So what do you? So in this case, which group? So you're having girls standing. In one, they're all holding each other closely. In one, they're holding their hands, and in one, what they're doing is they're just touching each other with fingertips. So which chain can we break fastest?
Ma'am, the one with the one who are catching with fingers.
With fingers. So that means the force between them, the force between them is less, so we can easily break. But when they're holding themselves tightly, it is difficult to break. So that means we can conclude that there is some force of attraction between the particles. It can be more, it can be less, based on which we see differently. For example, if I see in this, the force of attraction between the particles is more, it is, we can say, considerably more than, let us say, in case of a rubber band. Rubber band, between the particles, the force is less. I can cut the rubber band, whereas I cannot cut this so easily. Okay, so this is with this I will conclude my class. So what have we learned? So Prerana, what have we learned so far? Can you summarize in a minute?
Yes, ma'am. Yes, ma'am. We got to know what is matter. We understood each and everything in the surrounding are made up of small particles called as matter. Matter is anything which has mass and occupies space.
Excellent.
We got to know that the characteristics of the particles of matter. They are particles of matter have space between them. Particles of matter are continuously moving. Particles of matter attract each other.
Very good. Sachin, so in this particular chapter, which property of matter are we studying? This whole chapter is based on physical property or chemical characteristic of matter?
Physical property.
Yeah, we are studying about the physical properties of matter in this particular chapter. So we have learned all this. Very good, children. You have any doubts? Anything that you want to know? No doubts. Okay, so I'm very happy that I'm very happy with the interaction. So next class, please do the 2 experiments. That is, one is regarding agarbatti, the other one is just observe the time taken by ink and honey to spread, and then we'll learn the next. We will learn the next aspects of matter, right? Types of matter we'll study. Clear, all of you students? So
Yes, ma'am.
okay, thank you
Yes,
all.
ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Bye, ma'am.
Have a nice day, ma'am.
Bye, ma'am.
Thank you, ma'am. Bye.
Bye, ma'am.
Bye, students. See you.
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.